All right, everyone. Welcome to another episode of the TWiML AI podcast. I am your host, Sam Charrington, and today I'm joined by Sebastian Raschka, an assistant professor of statistics at the University of Wisconsin-Madison, as well as the lead AI educator at Grid.ai. Sebastian, I'm really looking forward to digging into our chat. We'll touch on your research as well as your work in ML education. Welcome to the podcast.
Yeah, thank you, Sam, for the kind invitation to be on your podcast. I'm super excited to chat about research, education, or whatever you feel like chatting about today.
Fantastic. Well, let's start by having you share a little bit about your background and introducing yourself to our audience. How did you end up in machine learning?
Yeah, that is a good question. It goes back many years now, but when I was a PhD student, I was studying computational biology. And my professor back then, she recommended me taking this introduction to statistical pattern recognition class, which was a grad level class in the computer science department. And really that got me hooked. So that was mostly about like Bayesian statistics and Bayesian methods for pattern recognition. But somehow it clicked with me, and I found it super fascinating that you can kind of like teach computers how to recognize patterns in data. And from there on, I was just super hooked and studying machine learning. And then I ended up writing a book back then in 2015, Python machine learning. Joined the University of Wisconsin-Madison in the statistics department, and now at GridAI as AI educator. So it has been quite a journey, but I'm still as much as excited as I was back then about machine learning. So there's so much cool stuff coming out too. So it's an exciting field.
Yeah, absolutely. And your work, in particular around education, has been inspirational to a lot of people. I'll mention that you are a great follow on Twitter. We'll link to your Twitter handle profile in the show notes. And when I think about your take, it kind of reminds me of a little bit of the top-down approach that like a Jeremy Howard advocates, but also with that academic grounding of a bottom-up approach. And you seem to do a really good job of fusing those together. Tell us a little bit about what got you excited about the teaching aspect of machine learning and your philosophy around that.
Yeah, so it's kind of like related to what you just mentioned, like fusing the academic approaches, let's say the mathematical details, and then also the practical aspects. So personally, I must say I'm really I enjoy coding. I really like programming. It's something I do for fun on the weekends, and like also contributing to open source software. But then I'm also sometimes curious about certain things, how they work. So it's like maybe coming from academia, you are like taught to investigate, to make sure you understand everything you are using. And I'm trying to kind of bridge the gap between the two, that it's fun where you get to code things and these types of things, but at the same time you also develop an understanding of how these things work, because they make you, let's say, more powerful in terms of what to change and what to expect. It's kind of like a deeper level of understanding, and I think it's also very satisfying to know what's going on when you change certain things or when you code something up. And for teaching, that's a good point. I try also to combine the two. Everyone has different preferences, but when I was taking classes, I enjoy sometimes the mathematical details, but it's something I also I need to learn on my own time. It's for me very hard to sit in a, let's say, lecture and just see mathematical equations. It's often too fast for me even. So in that case, I try to balance it, that I don't, let's say, have slides full of equations, that I kind of change it up with big picture concepts and also code examples, because I think code examples are at least helping me a lot, like in terms of solidifying things I learned. And when I'm teaching at the university, I also noticed that students like this a lot. So it is a fun part. I think it's the reward. You learn something and then you apply it and see, wow, this is actually so cool. I want to do more of it. And then I think if you do it like this way, where you show cool examples and empower people to develop cool applications, people will automatically be motivated to learn more details. But if you start the other way around, if you teach people like the nitty-gritty details, I think it's easy to lose track and get bored. That happened to me like with mathematics when I was like in high school taking math classes. I wasn't really excited about that because it was like, okay, bunch of numbers, I can move them around, cool, but why is that useful or why is that cool?
Yeah, yeah.
And yeah, with coding, you can immediately see what you can do with it if you develop like your machine learning applications. And yeah, in my class, I make sure that there's a decent portion of that. So I also have these class projects I like my students to work on, where at the yeah, I would say middle of the semester, the students submit a proposal, project proposal. It could be anything they are interested in. It just has to be related to machine learning or deep learning. And then they get to work on it for the rest of the semester, while of course taking the lectures. But I think so based on hearing from students, that was really the fun part because at the end they work in teams of three. At the end they have like the teamwork experience, they develop something, they have something to show for. So we also have presentations in class where the students get to talk about their project in front of other students. And then in the end they have I mean, I make this voluntary because I don't want to force anyone, but they can share the project, let's say on GitHub publicly. And a lot of students like that because then when they apply for jobs, they can actually show the yeah, where they apply, they can show, okay, I've actually done something cool here with machine learning, I know how it works. I mean, of course, you can't expect in a semester to build like this huge AI system, but it is at least something cool. I mean, there were so many cool projects in the last couple of years that I've seen. I was really impressed, and I think it's fun for me to see all of that, but also fun for the students to yeah, proactively work on that and develop their skills. So yeah, so that's my approach to teaching. Basically, I make sure, or I want to make sure that students also get this practical experience because I think it's also very important and motivating.
Do you think about it from a pedagogical perspective, or is this just kind of how it all naturally came together for you?
I'm not that good at, let's say, reading literature in education and figuring out what is the best approach to teaching. For me, I mostly go with gut feeling. Honestly, how I do these things is really I'm thinking about what do I like, how do I like, let's say, consuming information. Is this too much math? Is this too much code? Is that the right balance? Would I be excited about this? And it's basically just that, like being myself, motivated and excited, and then just going with it. I think.
That's awesome. That's awesome. You did a workshop or participated in a workshop teaching machine learning at ECML last year, and did a session deeper learning by doing integrating hands-on research projects into a machine learning course. And it sounds like that in some ways you sharing all the things that we just touched on your experiences teaching. Are there for folks that are maybe putting together courses, are there interesting things that you've learned about how to integrate projects in? Are there things that work, things that don't, or is it more about be sure to focus on and include practical hands-on projects versus not?
I think this is one approach of doing it, but it's maybe not the perfect approach. But one, I would say, one downside of a project is that if you imagine students taking the first machine learning class or deep learning class, they don't know what you can do with machine learning. So um, the one challenge I found is, yeah, ideally you want to have more time so that students can work on the project more. I mean, let's say stretching it out over the whole semester. But then the problem becomes that if people have not encountered machine learning or have learned about machine learning, it's hard for them to propose a project centered around machine learning because at that point they may not know what's feasible or not. So in this proposal that I make them submit at this middle of the semester, I also give them feedback. But yeah, it is the middle of the semester where it's kind of like a little bit late. And then also one downside is that they haven't seen all the methods yet that we get to cover in class because the class still goes on. But despite that, I mean, these are little downsides. I think there are lots of upsides where people really get to get to use the methods they learn about. And here I find also it's helpful to have homework examples where students get like also understand the details where um, in the beginning it might be harder to really develop a machine learning let's say pipeline from scratch because if you're new to it there are so many things to think about. So what I found works well is providing template code and then leaving out, let's say, core parts of the code, like for example here we have the framework of a model, add another, let's say, activation function or something like that, something little small. And students will think about these things like how to do that, but then also have these templates that they can reuse in, let's say, their class projects as a framework. So I think this is helpful to provide students with ample examples like frameworks in terms of code that is self-contained and works. Of course, they will adopt it for their project, but it at least something to help them so that they don't have to do everything from scratch. Because I think this is one intimidating thing about machine learning. There are so many tools and so many frameworks, especially for deep learning, that it's a lot of code and it can sometimes be a little bit overwhelming. And then kind of like managing that by showing a lot of examples and providing templates, I think it helps.
What do you find is most challenging for folks just getting started with machine learning?
People who want to use machine learning, one challenge is how do I get my data into this machine learning model? I mean, there's machine learning and let's say the non-neural network deep learning part, where these are also two different cans of worms. But scikit-learn on the surface looks very simple, right? Very simple to use. It's like a few lines of code where you can fit your classifier. But I think the main challenge is really preparing your data, especially if you don't want to do something like iris flower classification. I think, the biggest challenge is students have so many cool ideas for their class projects, but then it's always about how do we make sure this data is the right format for my machine learning classifier? For example, if we are using scikit-learn, this is usually a tabular data set. So we have to make sure we have class labels and then also the columns, the feature columns. And for deep learning, okay, it's a little bit more, I would say, raw, where you can work with image data directly or text data, but still thinking about how to organize your data. That is one challenge, I think.
In chatting earlier, you emphasized you really take a lot of care to make sure you walk through kind of classical machine learning before diving into deep learning. Talk a little bit more about that and your experiences there.
Yeah, that is a good point. So in my book, it's a pretty long book. So it could have been two books almost. So it is,
If
wow.
folks can see it, it is a thick book.
Yeah, we'll keep you busy for a while. But it is essentially, you can think of it as two books, a machine learning book where you get to learn about the basics of machine learning, model evaluation, hyperparameter tuning, all the basics in the context of scikit-learn and tabular data sets. And then the second half, I think chapter 11 or 12 is the turning point where I explain how to implement a neural network from scratch using NumPy. And then from that, it starts with the deep learning parts. And so I feel like, okay, this could have been two books, but nowadays I think there's deep learning is so powerful and so, let's say, exciting that a lot of people sometimes forget that there is also non-deep learning, machine learning, where I think that there's still a place for that. If you especially look on Kaggle, a lot of competitions are still won by XGBoost, which is a gradient boosting classifier for tabular data. And honestly, I would rather say it should be kind of like, I mean, machine learning is still, like the non-deep learning part, a good baseline, but also depending really on your data set, how much data do you have and what format your data is, you want to use one approach over the other. For example, for smaller data sets or tabular data sets, machine learning might be, let's say, the way to go, whereas for a large image data set, you may want to go with deep learning. But still, you could apply a machine learning classifier as the baseline, like logistic regression or something like that. So in that case, with that book, having both machine learning and deep learning in there, I think it is kind of like a reminder to people, hey, it's not always about deep learning. Also consider, let's say, sometimes machine learning. Making sure that people who, let's say, have their first encounter with machine learning and deep learning, that they know the big picture, basically, that there's more than just neural networks also.
You mentioned earlier just the proliferation of frameworks in ML and DL. How do you advise folks when they're thinking about projects? Where to start, what frameworks and tools to choose, that kind of thing.
Oh yeah, that is also a big question. I think, I mean, again, there is no right or wrong. I would say there are just different tools for different tasks. Personally, I started with, I implemented a lot of things from scratch because this is a good learning experience, but in the real world, I advise people to use something that is well supported, well developed, because It's not only about, let's say, having it bug-free or error-free, but also about efficiency. So, and there are also, if you use something that is out there, there's also usually a wider ecosystem and a community that you can ask for questions and help, which I think is also very important. Because nowadays there are millions of algorithms, and it's hard to find sometimes which one is, let's say, the right one. And sometimes just asking people, chatting about it is helpful. And yeah, for regular machine learning that is not deep learning, I would advise scikit-learn still. I think it's the maybe most mature library out there. People in my department may disagree because my department is more, let's say, R based, the language R. But I personally, I think going with Python if you want to do machine learning or deep learning is the way to go. So one consideration is, yeah, which programming language. I think nowadays 95% or so is done in Python. And then scikit-learn for machine learning. And deep learning becomes a little bit trickier because we have a lot of more frameworks out there. So back then, I remember my first book, I covered Theano, which I think is still around. The people at PyMC 3, I think they adopted it and still maintain it. But I don't think people use it for deep learning anymore. So I think it was like 2000, might be 15, 16, where TensorFlow came around, which is maybe the first big breakthrough library for deep learning where it became really, really popular. And then, yeah, there were other libraries like MXNet, Chainer, and so forth, and then eventually PyTorch in 2017. And I think nowadays, when I look at the trends on papers with code and just reading research papers and looking out there, I feel like I would say like 80% now is PyTorch. And I would say with PyTorch, it's a two-edged sword. It's a little bit more verbose, let's say, than Keras, but at the same time, for me, it makes me more productive in my research. I wouldn't say it's necessarily better for everything, but I feel like personally, it strikes a nice balance between giving you all the tools you need, but giving you also some control over what you're doing in case you need to modify something. Because yeah, in my research projects, unless it's just an application, I sometimes want to develop my own custom layer, like a custom output layer or custom loss function. And PyTorch is very fast for that. And it is a little bit, I would say, more low level. So there are also other APIs on top of that, and there are a lot of APIs on top of that. But in general, I would say for deep learning, I would personally recommend PyTorch nowadays.
Yeah, it's interesting that you mentioned R. I don't think I've covered R a lot on the podcast, but we did have this really awesome uh, panel that we did that was exploring what's the best programming language for machine learning. And we had representatives from like, I think eight. It was like Clojure and JavaScript and Swift and Scala and Julia. There's certainly a ton of different well, you can do machine learning in a lot of different languages, and starting with what you know is always a good place, or not a bad place at least. But the Python ecosystem is certainly very strong.
If you don't mind, I can tell you two anecdotes. So personally, so the first thing is when I was a student back then, I also started with R before I started Python, and I was doing most of my statistics stuff and plotting in R. And then I ended up in the computational biology context. I ended up having to process some custom data, and that's where I learned Python just for the data wrangling. I learned a little about I learned about Perl, but Perl was a little bit unwieldy for me. So I heard Python is the hot new thing, so I learned Python, and I was writing these really weird scripts. I had like a bash script that was calling Python for processing the data and then ingesting it into R to make the plots. So for a long time, I just used R for making plots, but the rest was in Python, and then eventually I switched. But one thing you mentioned is about also deep learning and machine learning in R. I was recently at a seminar at our university where there was a talk on, it was in general about like machine learning in industry. And the person also presented, I don't want to say like names or anything, but it was kind of funny. It was like more like a fun thing. The person mentioned that they were training a model in TensorFlow, and they had presented the results in a conference in an R related conference. And I was like, How does wait? You trained this model in TensorFlow, but you presented in the conference that is related to R. How did you do that? And then the person said basically, don't tell anyone. But I used the just the API. I did it in Python and just used the R API or something like that, so that it can be submitted to the conference. But it was under the hood basically TensorFlow and Python and stuff like that. So
Now
yeah.
I see why you weren't naming names.
Well, it's kind of funny though. It's like that. I mean, R is still. I mean, I think it has its place for sure. I think it's very user
Yeah.
friendly, especially for statistics. And as soon as you need to do some, I don't know, just hypothesis testing in statistics, there is of course stats models, but it is just so many extra steps. And I feel like R comes with a lot of batteries included when it comes to statistical modeling. So I think it definitely has its place. And of course, like you mentioned, Julia, I also have a few colleagues who work in Julia, and my colleagues who use Julia, they really love Julia. It's like I think it's a really nice language. It's just for deep learning. I think it hasn't caught on yet, and I think it's maybe like a chicken egg problem where you don't have the community in Julia for deep learning, and without the community, you don't have, let's say, the libraries that support deep
Libraries and
learning.
frameworks and
Yeah,
yeah.
I mean, it's possible for sure. And another name I don't want to mention, but I was on a committee, a PhD committee, and the student did some research on deep learning, like developing some custom methods, and was using Julia for that. And in the end, the student mentioned to me, I wish I had used PyTorch because it made certain things more elegant if you wanted to do things from scratch, because you have this array type in Julia and so forth. But overall, just the lack of the framework. I think they have a library. I forgot the name. Is it? It's not Flux. I forgot the name. But it is not as mature, let's say. And then once you want to compare your methods to other methods, you bump into problems because yeah, you can either compare across languages or you have to re-implement everything. And I think that is also one important consideration. You want to maybe look at what other people are using, not because you want to copy them, but you want to maybe also compare your methods, especially if you want to develop a new research method. It's good to have something out there that is also useful to other people. So if, let's say, other people are using your framework, it's a higher benefit for the community if you contribute it in that language. But then also, if you want to make sure you make progress in research, it's easier to compare. If you make a small change to the loss function, it is easier to compare that to the reference in the same framework compared to, let's say, another framework, because then you don't know, is this because of numerical approximation, is it due to something else, the improvement? So yeah, I think there's a lot of benefits going with what everyone else is using, although I usually try to do something different just because it's exciting, but there are definitely benefits. Yeah.
Maybe a little bit more about the book. Did you find a way to incorporate this idea of of projects into the book?
That is a good question. Unfortunately, no, there are only like more like toy projects.
Okay.
Yeah, the problem is, I think
It's really
project.
hard to do. I mean, there have
Mhm.
been some great not necessarily machine learning books that I'm thinking of, but just computer programming books that the ones that I like are the ones that I've liked the most are the ones that kind of take this longitudinal project approach and it kind of flows from the beginning to the end and adds, each chapter will add on to the project. But I've got to imagine that that's really, really difficult to do.
Yeah, yeah. Now that you mentioned it, I remember that I was last year reading a book, Introduction to PyTorch, I think, or Introduction to
Okay.
Deep Learning with PyTorch by Eli Stevens, Luca Antiga, and Thomas
Okay.
Thiemann. And they had something like you described. The first portion was an introduction to PyTorch, and then the second part of the book was a very long example explaining, I think it was an MRI example, like object detection and these types of things. But it was like this huge project that they walked through. And I think this is very valuable because there's not much stuff like that out there. But the one thing you mentioned about involving people in the project, the problem here is really this how you scale that up. Because in my class, I had usually 70 students, and I was just at the limit of my capacity. When the students submitted their proposals, I spent multiple weeks reviewing them. There were only 2 pages each, but if you have 70 students, groups of 3, you have like 24 groups, approximately 23, 24 groups. And yeah, reading 23 like short papers and then thinking about them, giving feedback, that is a lot of time. And then the same thing for the final project, which was in the format of a 8-page paper, a conference paper. Yeah, this keeps you busy, especially if you want to also during the semester provide feedback. So with a book, I can see the challenge is yeah, you can describe a project, but it is hard to give feedback if people are, it's if you give an open-ended exercise or something like that. But I think maybe that's what Kaggle competitions are almost for, where you have also this community around it, where people work on a similar project and then they can help each other with feedback and so forth. But yeah, I think projects are very powerful, but there's still like the issue of how to help people with that, like in terms of having the time and capacity for that.
You mentioned PyTorch Lightning earlier. Can you talk a little bit about that and what it is, how you use it?
Yeah, so PyTorch Lightning, I must say, I just started using it recently, earlier this year. It is essentially, I wouldn't call it a framework. It's more like a platform. So it is in a way an API that organizes your code, but it is more than just a framework. It's like, I would call it more like a platform because it helps you integrate other technologies as well. So it kind of brings together multiple things, because when we do like deep learning now, what I usually tended to do in my research projects, even, I try to write everything from scratch. I mean, using PyTorch, but then I had my training loop. I had like a function that iterates over the data set to compute the test accuracy, because you can't load the whole data into memory because it's too large. And then also logging. So I had my own loggers where I was writing to a CSV file, for example, or sometimes using weights and biases, or even just a tensor board. And I was just putting everything together myself. And I think this works if you work alone. But then also I noticed like 3 months later, coming back to the project, I had like 20 helper files that I was importing from. I wanted to change something. It was like a mess. So, and also when I was collaborating with students, if you have your custom code, it makes sense to you, but it doesn't make sense to anyone else. So PyTorch Lightning, yeah, it's basically it's not much in a way that it's not much different, let's say, than PyTorch. It's more like on top of it, but it helps you integrate different other tools without having to, let's say, reinvent the wheel. So what you do is essentially you can still have your regular PyTorch model. So you don't change anything about that model. It has your regular forward method and so forth. And then you have a Lightning module. And this is like a class that wraps around the PyTorch module. But when you do that, you have still full control. You define, okay, how does my forward step look like? So the forward step for training or testing. And you define an optimizer. And then you have a trainer class. And this is it. And what's nice about it is, in the trainer class, you can specify what type of logger you want, like weights and biases, TensorBoard, a simple CSV logger. And what's really powerful is you can specify how many GPUs you want. So, I mean, you can do this in PyTorch, but it's much more extra work, and I never really got it to work myself. So right now, for my research projects, I was just using the same code I had, was wrapping it around a Lightning module, and I was just training it on multiple GPUs. So in that case, I mean, it's also fully open source, and if you want, you can still access the original PyTorch model. It's really just a wrapper around it that gives you certain things for free, which is nice.
I'm curious, what's your sense for PyTorch usage beyond? Is it still primarily research oriented? Do you have a sense or visibility into whether it's seeing broader adoption in industry and in commercial context? I still see a lot of TensorFlow out in that context.
Yeah, that is an excellent question. I honestly, because I'm coming more like from an academia background, I must say I haven't really deployed anything myself yet. But talking to colleagues, it really, I think it really depends on uh, the company you work on. I mean, some people similar prefer one cloud provider over the other. It's one framework over the other, but there is no, I think, big limitation of using PyTorch anymore for, let's say, deployment. So they have. So I'm not super familiar with how things work under the hood. Sometimes I look at the source code and it's really scary for me, like seeing all the C files and stuff. But so how I understand it now is that you have Python where you run PyTorch in primarily, and the bottleneck of using Python is just like 10%. Like if you would remove Python, just run the code without Python, it would be maybe 10% faster. There's not much of a difference, and they have Two different ways you can go from that to C code. One is, I forgot the names actually. One is essentially tracing your code, where it's really a static graph from that, where if you have a for loop, it gets unrolled is this static one. And then they have the other approach, which is, I think it's called Torch script, where you go from this Python API to I think it's called libtorch, which is like the C++ API. And that one can be just used anywhere. I mean, I think they have a lot of tools in the recent versions also for mobile deployment and stuff like that. So I think, to be honest, there is no really bottleneck, no big bottleneck anymore, like using it for serious applications. And then also you have all the quantization things to make it faster. So I think this is all really like what they focused on last year to make it more deployment friendly. Oh, one more thing just comes to mind is Onyx, like the ONNX format, where you can also export PyTorch models to ONNX, and I think you can then also use it in like the Apple framework. I think Metal and Core ML, but this is something, to be honest, beyond my comfort zone. I'm more like, let's say, research education. I am not really someone who is deploying applications. So yeah.
Let's maybe switch gears and talk a little bit about your research. You're most recently you've been focused on ordinal regression among other topics. Can you share a little bit about that field and why you find it interesting and kind of what the research frontier is there?
Yeah, that is a good point. So ordinal regression, it's maybe an abstract term, but how we can think about it is, how do we use methods when in a supervised learning context, when the class labels have a natural order? So usually when we teach or use machine learning, we have like these two different scenarios, where one scenario is classification. Let's say iris flower classification. We have setosa, versicolor, and virginica. But we can't really say one is, let's say, versicolor is bigger than virginica. There's no order. It's just independent class labels. And then the other type is regression, where we have, for example, I don't know, house prices or something like that, where you have a numeric or continuous target. And ordinal regression sits somewhere in between, where we have something that looks on the surface like classification problem, but it has an order. And so the class labels have an order. For example, Amazon customer ratings, where we have 1, 2, 3, 4, 5 stars. And I mean, it could also be kind of like a regression problem, but the difference is really we don't know, or we can't quantify the distance between things. And we can say, okay, 1 and 2 stars and 4 and 5 stars, it is 1 star difference, but yeah, it is a little bit more, I think, tricky than that, because it's hard to compare a 1 to a 2-star review to a 4 and a 5-star review. It's hard to quantify this distance. And the same thing is true like for, let's say, other things like disease. If you have a scale between no disease, medium or mild disease, and severe disease, it's hard to put a label on it how different these two distances are. And this is really where you don't want, so ordinal regression is where you don't want to or can't quantify the distance between categories, but at the same time you have ordering. You can say that, for example, no disease is less than moderate, then less than severe. There's like an ordering.
Would you specifically use it? I'm thinking about it in contrast to like trying to attack a regression problem where you're concerned about integer values. Would ordinal regression be used when you've got a much smaller set of labels, or can you use it if your set of labels is relatively unconstrained and you're just really trying to focus on integers?
Yeah, that is a good point. Actually, there is no limit to the number of classes. So in our first paper, we focused on age classification, where we had 70 different age labels, like from 1 to 70 years. And also we thought, okay, age, I mean, this could be modeled with a regression model, but it's a little bit trickier than that, because if you think about a person who is, let's say, 10 years old and the person who is 15 years old, there's a lot of change that takes place when a person becomes older in that 5-year time frame, compared to, let's say, a person who is 80 and 85, where in this age frame, maybe the texture of the skin changes mostly, whereas for a younger person, it's maybe more like the growth, like the bones change and so forth. So in that case, yeah, you can use it with any type of labels, but yeah, you're really flexible with that. So, but what I feel like was people, or let's say when I look for tutorials or anything like that, there has not been much attention, or people were not really providing, let's say, help or tutorials or methods for how to do that with deep learning. There is the classical statistics literature where we have ordinal regression models, but nothing really for, let's say, deep neural networks. So if you have an image data set and you, let's say, want to assess the damage to a building, you can't really say, so if you have like a collapsed roof versus like a scratch or something like that, it's a different type of difference compared to, or it is hard, let's say, to quantify things sometimes. You can try to put numbers on it, but really there are a lot of problems where there are no numbers that you can put on it, but you still want to, let's say, train a classifier to recognize more severe damage compared to moderate damage or no damage, let's say in terms of insurances or buildings and so forth. And yeah, so we have been focused on developing deep neural networks for that. But then also the challenge is you don't want to, let's say, develop a completely new type of neural network, because then it's really hard for people to use that and to compare to other methods. So the focus was essentially what are like small changes that we can make to modify an existing classifier such that it becomes an ordinal regression model. And I think this is really cool because that allows people really to take something they already trained and then just change a few lines of code and see if it becomes better. If it doesn't become better, okay, maybe I spent 5 minutes making that change, no big loss, but maybe it makes things better. And then I think it's a huge win when people can just improve their model without having to spend a lot of time developing something completely new. Yeah, and so there are, I'm not sure if you're interested, there are a couple of methods for that I could talk about. Oh, sure. Yes. Okay. One method was from 2016. It's not by our group, but it is. It was published in CVPR. We call it just the ordinal regression network by New et al. Yeah, and so how they tackled that problem was by it's something called extended binary classification. So they take a class label. Let's say you have 5 different classes, and you have the class label 3. So what they would do is they would extend this integer number into 4 zeros and ones. So you turn this multi-category classification problem into multiple binary classification problems. And then you are predicting, is my label greater than 1? Is my label greater than 2? Is my label greater than 3? So you have a lot of, or you have, let's say in this case, 4 different yes and no questions. And then you can just and so if the class label is 3, you answer class label is greater than 1, yes, greater than 2, yes, greater than 3, no. And then you can, based on that, sum up the ones, add a 1 to it, and end up with a label. And yeah, each problem is then modeled as a binary classification task. So we can use something we're familiar with, like yeah, the logistic loss function, the binary cross entropy loss, and then sum up these binary cross entropy losses. And so this worked really well in that paper when they had that.
Sounds a bit like an extension to one-hot encoding for categorical
Yeah, yeah,
variables.
yeah. It is kind of like that, right? So except you can have multiple ones basically instead of
Yeah,
just one.
right.
Yeah, but it is kind of like an encoding, right? Right. You turn this
Hmm.
problem into a multiple binary classification tasks. The one little problem with that was when you do that, you can have like rank inconsistencies. So what happens, let's say in an age prediction problem, you can predict that the person is older than 41, not older than 42, but older than 43, which is like conflict. How can a person be not older than 42, but then older than 43? So yeah, in our work, we just, yeah, it was like a little bit of math we did there. And then we had like a small tweak to prevent this rank inconsistency. And we found that this also, yeah, improves prediction performance by a lot. And it's a really small change. And altogether with this method, we call that a CORAL, CORAL, and it stands for consistent rank logits. So with that, you only have to do 2 small changes. So you have to change the last layer. There's like a constraint we have in the last layer, a weight sharing constraint. But I have like a PyTorch package. You can just import the layer and just use that. And then the other one is the loss function. And this is really it. So there are like 2 little changes to the code. Maybe the binary extension could be also considered as a change to the class label, but it's really something that you can do in 5 minutes, and then you have, instead of a classifier, an ordinal regression model. And recently we have another method called Corn, C-O-R-N, which is taking this to another level. It's a bit more flexible. It has better performance than Coral. It is a little bit more, you have to be more careful because with more, let's say, power comes more responsibility, so it's easier to overfit. Yeah, so these two methods, what I like about them is really they are very easy to implement, and everyone can use them. If you're using a classifier, you can just change a few lines of code, and yeah, you have an ordinal regression classifier.
Maybe to close things out, we'll return a little bit back to education and talk about your recent role at GridAI and kind of what you have planned there.
Oh yeah, that is a big question. A small, short question at first glance, but there is a lot of things behind it. So yeah, I have been recently joined GridAI, which is focused on deep learning at scale. My role there is though lead AI educator, where I'm developing educational materials. So I'm essentially just doing what I love doing. I'm developing material to explain machine learning and deep learning to people. And in this sense, what I felt like also is I like teaching at the university, but also, let's say, going the next step, maybe having a more like online based, or like a course that is accessible to everyone. Like my plan is to develop a free course that people can take. There's no like restriction, nothing. It's a totally free course, and also, let's say, nicely produced with where I get to focus on, let's say, making this really nice and also involving the community with feedback. So yeah, that is what I'm currently working on. It will be firstly, my first goal is to have something out maybe later this year, focused on PyTorch, maybe also Pytorch Lightning, so something around that. So I'm currently working on that, and yeah, I'm really excited because I think that's like my passion. I wrote like as a book recently, but I also now that I have a book, let's say, going back to the course development, developing courses. What I really like about that is also thinking it through. It's like it is something where you get to get creative and you think about, okay, how should I cover what? And in the past, that was always like, I think you have to do it in order to see what is like the pro and con of introducing a topic in a certain order. And this now offers me another attempt doing that, like seeing how I can structure a course and how I can develop a course. And of course, tinkering with code. This will be also a very code-focused course, and hope I can also develop good exercises, because I think that's also very important. There's a lot of material out there, but to really learn things, it's important to apply these things, and also checking your understanding with having good exercises. So I'm currently working on developing all of that, and hopefully I will have something by the end of the year that I can share with you and the community, and you can then tell me what you think.
Well, we'll be keeping an eye out for it. In the meantime, thanks so much for joining and sharing a bit about what you've been up to. It's been great finally meeting you.
Thank you. That was a total fun episode here, and I think I could go on forever, but it was nice chatting with you, and I enjoyed it. And whenever you feel like it, I'm always open to talk more.